Hi everyone, hope you're all doing well. Today we are going to do some application problems involving the law of sines and the law of cosines and even the area formulas that we talked about the other day. So our first application has a boat going on a boat race, and the boat race starts at point A and proceeds in the direction of south 52 degrees west. So we're going to have to remember what bearing deals with. To point B, then in the direction of south 40 degrees east to point C, and finally we go back to point A. Point C lies 8 kilometers due south of point A. Okay, that's pretty important to remember. And they want us to approximate the total distance of the race course. So it sounds like we're finding the perimeter of a triangle. All right, so our boat is starting at point A. And you remember with bearing, we need to put our little compass rose in the middle of our point, and this is going in the southwest direction, so that means it's going down this way. And with bearing, you are always going off of the y-axis, so this angle is 52 degrees. So it's going down to a point, go back to my color here, to a point down here, we'll call this point B. Then from point B, the boat is going to change course and it's going to go to point C, and it's going in the south and in the east direction. And so that means that this would be the angle going off of the Y, and that would be 40 degrees. A little distorted, but we get the idea. And then due south from this point, we have point C directly south of A, and they tell us that this distance here is 8 kilometers. And so our job is to figure out the total amount that the boat raced in this course. So we would have to find little side C over here and little side A, and then add it to 8. All right, so we're going to have to use some geometry skills. We know alternate interior angles. If this is 52 degrees, this is also 52 degrees. And hopefully you see that this is a line, so we know that this is 52 and this is 40, so that would make this interior angle in here inside that triangle 180 minus 52 minus 40, and so that turns out to be 88 degrees. And so now we know this angle is 52 and this angle is 88, so that would mean that angle C down here, if I subtract it all from 180, this would be a 40-degree angle. And now we can set up our law of sines to find the missing sides. So little a over the sine of 52 equals 8 over the sine of 88 equals c over the sine of 40 degrees. And now you can find, using your law of sines proportions, that a is equal to 6.3 and c is equal to 5.1. And so now you'll just have to add up all of those sides to find the total distance that the boat raced on the course, and I get 19.4 kilometers when I add those all up. So there's an example of one where you need to choose to use the law of sines depending on the given information that they gave you. Oh, and here's the work for it right here. Didn't even realize that was in there. Okay, the second one. Application 2. We have a circular arc of a railroad curve, and there is a chord length of 3,000 feet and a central angle of 40 feet. First, they want us to draw a diagram, show the known quantities, show the variables r and s to represent the radius and the arc length, find the radius and find the arc length. Okay, so we're talking about a railroad curve. So a curve would be part of something that would be a circle. And a central angle, hopefully you remember from geometry, a central angle means that you have an angle where the vertex is touching the center of the circle. And they are telling us that's 40 degrees. A chord length, a chord is a line that goes from 2 points on the circle. So this chord length here makes up a triangle, and that side is 3,000 feet. The other two sides of the triangle would be the radius of the circle, so they would be equal distance. So that also means then that these angles here in the circle or in the triangle would have to be equal in measure. This is an isosceles triangle. So in order to figure out those angle measurements, we could take 180 minus 40, which is going to give me 140, and we can divide that by 2, And so that means that both of these angles are 70 degrees. So in order to find the radius of the circle, we have a law of sines problem. The side across from 70. Okay, go away. I don't care about the battery. That's nice. Okay, so the side across from 70, if I can get this thing to write again, there we go, is R. So we're going to set up our law of sines proportion, and the side across from 40 is 3,000, and so there's our law of sines. So if we solve this proportion, turns out our radius will equal 4,385.7 feet. So that's the length of the radius. Part C goes on to talk about the arc length. Well, we talked about arc length at the beginning of trigonometry, and arc length is this piece out here on the circle. So they're talking about that circular part on the circle. So arc length formula is S equals R times theta. Well, we know our radius, we just found it. And theta, the theta they're talking about is the central angle, but hopefully you remember you need to convert that central angle into radians because we can't put it in degrees into this formula. So when you reduce this, you get 2 pi over 9, although you're going to be putting this all into your calculator anyway. And when you multiply, you get 3,061.8 feet, which you can see the arc length and the chord length are pretty darn close to the same length. The arc is just a bit longer. It's a little more curved, so there's a little more distance there. Okay, there's the work for that. I think we can skip. Number 3, pitcher's mound on a women's softball field is 43 feet away from home plate, and the distance between the bases are 60 feet. The pitcher's mound, by the way, is not halfway between home plate and second base. How far is the pitcher's mound from first base? Okay, so we're talking about a softball field, smaller than a baseball field. Getting the girls in there. So we have 60 feet here, and the pitcher's mound is only going to be 43 feet away from home plate. Hopefully you realize that it makes up a diamond, and at each of these 4 corners we have right angles. So what happens with the pitcher's mound and home plate is it bisects that right angle, and so you have here a 45-degree angle. We want to try to figure out if the pitcher doesn't move off the mound and they field a ground ball and need to throw to first base, how far are they throwing? So we're finding this side right here, X. So let's see what we know. We know 2 sides on the triangle. We know the angle opposite. So to me, this would be a law of cosines problem. So we got to bring back our law of cosines. So the trickiest part sometimes to these application problems is not only drawing what's going on, but also deciding what you're going to use to solve. So here we have a side angle side, so we obviously are using the law of cosines. And that's our law of cosines, and we put this into our calculator, and we find out that it's approximately 42.4 feet over to first base. There's the work for that. We can skip it. And then finally, we have here a ship, and he's traveling from point A to point B, due east, and then they adjust their course northeastward, and then they travel 80 miles northeast. And now the ship is 139 miles from its point of departure. Find the bearing from point B to C. Okay, so here's another one where we have to draw a picture of what's going on. Here's point A, and they said that point B was exactly due east, and that this is 60 miles. Then we're going to change our course. So there's our little compass rose, and we're going in the northeast direction. So northeast direction would be this way. And it's going to travel 80 miles to point C. And then to go from back to where it started from point A, they told us that this is 139 miles. And that's not degrees, that's just 80 miles there. Okay, so our job is going to find the bearing from point B to C. Well, bearing always goes from the y-axis. So we need to figure out this angle. But with what we know, we have side, side, side given. So we can find this whole angle, and then that'll help us to find the bearing. So since we have side, 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 we are using the law of cosines again. 139 squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of the angle theta. So you put all that in and you do the inverse cosine, and I got 166.2 degrees for theta. Now remember, bearing just goes off of due north. So we're going to subtract 90 degrees from this. And so the bearing is 76.2 degrees, and this is in the northeast direction. Okay, we can skip that work. And finally, we have here an ACT challenge problem. So here's one that appeared on the ACTs at some point, and you can see that they gave you the 3 vertices, and they want to know what the area is. Well, obviously, this is an oblique triangle, much like we were talking about the other day. And so we have some formulas that we could use, and it might look like it might be easiest to find the distance of the 3 sides, and then we could use Heron's formula. As it turns out, if you do the distance formula from A to C, remember the distance formula is the difference in the x value squared plus the difference in the y value squared, and then you take the square root. That turns out to be the square root of 13. So this side is the square root of 13. If we do A to B and do the same thing, it turns out that that side works out to be the square root of 5. And C to B, you can kind of just do this because it's on a straight line. You can see the y values are the same. So the distance from 1 to 5 is just 4. So it might be kind of hard working with square roots. So maybe you might want to think about getting a height of this triangle. And if you compare point A and point B to each other, you can see that the vertical distance is 2. So this makes a right angle with our base. So we can go back to 1/2 the base times the height, and you can see that this problem really isn't all that difficult, and the answer is 4. Okay, so you have some practice problems to do. Worksheet, day 5, you're going to be dealing with word problems and figuring out, would you use the law of sines, the law of cosines? You could even have some area questions figured in. Good luck, and if you have any questions, join me on office hours.